I'm going to show you that we're still using a 100-year-old technology to teach data science. I am Chiara Farronato. I'm an assistant professor at Harvard Business School. And for the last 3 years, I've been teaching data science to managers. And I'll be telling you what we've learned so far. Caveat, so far we've taught it as an elective course. It's just been approved to become a required course, so all our MBAs are going to go through parts of this course. It's very exciting, and hopefully it's going to be a success, or else I'll probably be looking for another job. Anyway, so whenever I say, that I teach data science for managers at Harvard Business School, people ask me, how do you teach statistics with the case method? And that is a very reasonable question to which I only have a partial answer. But one of the things that I strongly believe is that our objective is not to teach statistics. We're really teaching something else because our students are managers who are going to be working with data scientists, are going to be working with engineers, but they are not going to be the data scientists. They are not going to be the engineers. So what are we teaching them? Well, we're teaching them to work effectively with other colleagues with more technical skills. And that means being able to ask the right questions, even to ChatGPT, as we've seen. Prompting the right questions is crucial. And also understanding the answers. So ChatGPT can give you a bunch of answers, but you need to be able to understand it, sift through it, because ultimately you as the manager are going to have to make a decision and be responsible for it. And then we actually ask them to understand the possibilities that technology can provide. And this is a very humbling experience for managers, because by giving them an appreciation for the scientific method, we really are asking them to admit that they don't know something. Right? And this is very humbling. We also want to give them an appreciation for the value of different data sources and technical tools. And if there's one thing that I consider a success at the end of the class is if I manage to teach my students when do I have a prediction problem and when do I have a causation problem or causation question, that is a success. And finally, we want to teach them how to effectively complement domain knowledge with data insights. We want them to really understand what data can tell them and what data cannot tell them, and finally use their own judgment to make decisions, because it's ultimately going to be their responsibility to make them. And so these sort of are the large objectives of teaching data science, at least at HBS. And I'm going to use one example, which is this case, innovation at Uber, the launch of Express Pool. It's now an older case, but hopefully something that is still going to be teaching our students something relevant. It actually focuses on Uber's approach to product innovation. How does Uber innovate, right? And it uses Express Pool, now a defunct product, actually. It's carpooling with walking and waiting as the example of a new product launch. And the case describes both three major sources of data. Oftentimes we just think that experiments are the way to go. Well, no, we actually have surveys, and we should be able to understand the value and the benefits and costs of surveys, and how to complement them with simulations, and how to complement them with experiments. And then within experimentations, it discusses three types of experiments, because fundamentally, experimentation is not just a simple matter of randomizing users into a treatment and a control group. If I give 50% of you, sort of half of this room, a 50% discount on your next Uber ride, and the other 50% I don't give it, if you coming out of this room are going to ask more Uber rides, you're going to deplete supply to this group. And that creates huge, what we would call treatment and control interference, which gives you biased estimates to your experiments. And so those are some of the things that we are going to be able to teach our students. Are we going to teach them sort of how to code the experiment into Python? No, we're not going to do that. And the case really has this fundamental trade-off in product innovation. We want to make something that customers value as efficiently as possible. And so we're going to have in mind sort of this trade-off, product value at an efficient scale. Okay, so let me tell you a little bit about the case in one slide, or a slide that is going to be built. So the case starts from the perspective back in 2018 when Uber was really wanted to invest in carpooling, but their existing product, Pool, was completely unprofitable. They were losing money on every carpool ride, okay, on any pool ride. They didn't want to get rid of it. That was one option, and actually post-pandemic, they kind of got rid of it. But they didn't want to get rid of it at the time. They wanted to make it profitable. The case then describes that engineers, product managers, and data scientists really got together in these really tight rooms and got together and talked about all the parameters that they could tweak. And actually the case really gives them an experience of how product managers interact on a daily basis with other functions in the company. And that's one of the things that are very useful for our students, because they are going to be the ones who sit in those tight rooms and have those conversations with those colleagues. They decide on two parameters to tweak, right? Wait to be matched and walk to pick up and drop off location, right? What that means is that fundamentally we have a design space here where we have two parameters, wait time and walking distance, and we have an objective function that we need to explore. And all of the data sort of sources that we have, all of the experiments that we have are really helping us to explore this design space to narrow down more and more our product into the one that's more likely to work, okay, and work the best. So after that, they use conjoint surveys to bound the parameter space, right? So they used the fact that they could actually ask certain customers, what is the maximum wait time you're willing to accept? What is the maximum walking distance you're willing to accept? And that really sort of bounds your design space. What happens next is simulations are really fast and cheap, and they throw darts at these design space, right? You're able to sort of measure, right, or approximate your objective function, right, for many combination of wait time and walking distance. Well, why don't you experiment with all of them? Because experimentation is really costly. You have to really narrow down what happens for the various options and go to market, launch to market the one that makes the most sense and it's the least sort of risky in breaking your system. And then finally, what they do is a 12-city launch experiment, right? So they hold 6 cities in the control group. They launch this product with a relatively conservative wait time of 2 minutes in 6 other cities, and they want to keep this experiment going for 5 weeks. In the meantime, however, they run another experiment, what they call a switchback experiment. So just in one city, they kind of use time intervals to sort of switch back and forth between 2 minutes and 5 minutes to really explore this design space locally, right? What happens if all of a sudden we increase the wait time from the conservative 2 minutes that we launched with to 5 minutes? Clearly, 5 minutes is aggregating demand more, so you have more market liquidity, better matches, but people have to wait 5 minutes. Are we really willing to let people wait 5 minutes? So again, it's this trade-off between customer experience and efficiency. And the dilemma of the case is really at this point. The results of this time experiment have come in before the 12-city launch experiment has ended, and you have to make a decision, right? You have some results. You have to decide whether to launch the 5 minutes relative to the 2 minutes, and whether to launch it in the middle of the 12-city launch experiment or wait till the end. So this is the crucial dilemma. Try to put that into ChatGPT. He's not going to be able to answer that, okay? maybe GPT-10. It's hopefully going to get better, but anyway. So there's a data supplement for this case, and it's a pretty straightforward data supplement. It's nothing more than the data, it's synthetic but relatively realistic, the data from this wait time experiment, right? So you have observations where you have a wait time of 2 minutes, observations where you have a wait time of 5 minutes, so treatment and control. This is a switchback experiment. So again, every couple of hours, the algorithm in the city of Boston switches between waiting 5 minutes and waiting 2 minutes, and then you can compare those observations. And you have a bunch of outcomes, right? You have the number of pull trips, the number of these express pull trips, rider cancellations, payout, matches, double matches, and so on and so forth. And so we ask students a few questions, and you'll notice that only one of them is really data-driven. Many of them are around the process that Uber uses to innovate. What is the role of data science? What is the role of different data sources? Why does Uber have so many different ways to run experiments? And then we do have some questions around data analysis, which I'll go through in a second. And finally, we ask them what to do, okay? Let me tell you what we can discuss with this case in the classroom. Of course, you can discuss the benefits and drawbacks of surveys, simulations, and experiments, and also the complementarities of them. Students are going to be understanding why they can't just use one data source, and why all three of them actually in this innovation process have been really critical. Think about the design sort of space that we had right here at the bottom right of the slide as a way to further narrow down the range of parameter design parameters that you're going to launch with. You can also talk about different experiment design. Fundamentally, the level of randomization can be at the user, at the time interval, or at the market level. And again, this applies to Uber, but it applies to Airbnb. It applies to many other platforms where market equilibrium effects cannot be measured necessarily if you randomize at the user level, right? And again, you can talk about this in a statistical way. You can talk about bias, statistical power, you can talk about violation of sutra, or you can talk about them in an intuitive way, right? In terms of, how long does the experiment need to run to detect effects? Well, if you have very few observations because, you have the observation being the market level, you're gonna need to run the experiment a lot. Instead, if you have the user level randomization, you can run the experiment for a shorter amount of time. So these are kind of the intuitions that we want our students to build. And then finally, we ask them, considering the supplementary data set, what is the effect of extending match wait times from 2 to 5 minutes on the various outcomes? And what this allows our students to do is really getting to the hypothesis generation phase, right? How do you generate hypotheses over what your experiment, over what your control, what your treatment is going to do relative to the control? And what we're going to be able to differentiate between is efficiency metrics, right? If you extend wait times, you're going to have a much more efficient way of matching people, but people may actually increase cancellations. They may actually go to Lyft. They may go to other means of transportation, and you may see a bunch of reductions in your customer experience metrics. And then you can test them. And you can test them in many different ways, okay? So you can actually have students, what we found very helpful is actually using Google Colab. So we actually give students actually half-filled Colab notebooks. I'm happy to discuss them if helpful. But these are really kind of markdown documents where you can combine text, code, output from your code. And so students can actually read through them. They can play with the code. They can see what changes if they change the code and so on. And it's been a very effective way of having students learn to use code. And what is important is that when you give them some coding, you really have to plan for different student populations. As I said, we've sort of planned this course. For now, we've taught this course as an elective course, right? But even in a positively selected population of people who wanted to take this course, just it's not that they had to take this course, we had typically bimodal distributions of people very experienced in these topics and people not experienced at all, certainly willing to learn. But so you really want to make sure, especially when it comes to data, to plan for different student populations. So what does that mean in practice? Well, you can just tell them, add your comments here. ChatGPT may change that. But you can also plan for providing hints, providing solutions. Ultimately, we don't really care that they remember how to code a hypothesis test in R, Python, or what have you. We really care about their ability to interpret the results and make decisions. And so this is, again, more of a tool than the final output, than the final objective. And so you have the hypothesis testing, and then, you know, if you see the case, actually you have these trade-off, right? You have, on one hand, customer experience metrics may be decreasing, and efficiency metrics may be increasing. And so what do you do? What do you do? It's actually up for debate. Even within Uber, the case describes very different opinions over the decisions that different product managers and data scientists were willing to make given these results. Finally, you want to make sure you discuss what the data cannot tell you, because you don't want to sort of blindly follow data because now data is the new gold. There's a lot of things that this specific experiment cannot tell you, and we want our students to be, you know, intelligent users of these data. And so I started the presentation with how do you teach statistics with the case meta, and I don't think I've answered that question. Why? Because I actually assumed a lot of the knowledge around hypothesis tests as given. And if there's one thing that we've learned through the pandemic is really the huge power of asynchronous material, the value of asynchronous material. So what we assign actually to students now more and more at HBS, so that the classroom can be a flipped classroom, is a set of either technical notes or videos that allow us to really front end, like put in front all the technical knowledge, the basic technical knowledge, right? 5 minutes of video that's needed for us to have a meaningful conversation about the decision that these managers are going to have to make. And so just to conclude, you know, what data science still leaves room for is a lot of debate in the classroom. There's a lot of debate in these rooms at Uber, Amazon, etc., and we want to be able to recreate those debates in our classroom. We need to give students the basic tools to have those meaningful debates. And I think COVID taught us the value of asynchronous material, and we have to be cognizant that we want to design technical materials for at least a binomial distribution. And then finally, you know, those debates often mimic the type of discussions that data scientists, engineers, and product managers have in conference rooms at their workplaces. And so this is really the way we can most effectively help our students to be effective managers. And with this, I'm going to conclude. Thank you. Yes. So far, granted, we still haven't taught this class with ChatGPT, but what we have been doing is the following. So this is an example from another tutorial. This is Google Colab, right? So you can ask questions, right, to explore data, to analyze data, and then you can tell them, add your commands here, right? Like, add your commands, like we use R. It really doesn't matter. And you can do that. Or, so this is sort of the one for the more advanced students who really want to code, may want to get their hands dirty with R. And then for others, we provide two types of help. The first one is a hint, right? So really think through the logic of coding. Say in English what you would need to do, right, to run a hypothesis test. And then the final one is truly the solution, okay? You really don't want to get your hands dirty. I'm just going to give you the solution. Anyway, it doesn't matter that you come up with the solution. For us, it matters that you can interpret the solution. Yeah, so you can open these up. So they're closed, right? And so you can open these up, and we don't track what they do so far. We may use different technologies to track what they decide to do, but you can open them, right? No, not by default. It literally shows up like this. Yeah, no problem. Yes. Yes, so I think one, so let me start with the advantage of making it required. We have a pretty good set of norms at HBS, so the students actually are incentivized to prepare because they need to participate in class. They may want, but at least they need to. And so that is going to give us actually way more preparation than we've had with an elective course actually in the first year. So it was an elective course in the required curriculum. So on top of everything else that they needed to do, these students were actually deciding to do these in addition. So highly positive selection. The risks that we're going to encounter, and actually I was talking to Daniel yesterday, was the fact that we may have a lot of a huge distribution of people getting lost on small things, right? Like, oh, how do I open like a Google Colab? How do I, call on a variable in a data set? Or, I copy paste a piece of code, but it's not working here. Why is it? Well, because you called the data set in a different way, right? So we're going to have to be really, really careful with those. We're planning on having a bunch of teaching fellows that are going to have office hours and time open for these students. And when the course is required, we would expect that these students are actually going to show up and seek help. In the elective course, they weren't doing that as much. But it's going to be an adventure. I mean, if you actually have any risks that I should be able to face and respond to, please let me know, because I'm all ears. Yes. It is an addition to the core curriculum, and I think Feng is going to know way more about all of this, but it is an addition to the core curriculum. There's been a bit of an adjustment to the other courses to reduce some of the workload to other courses, but it is an addition. It hasn't replaced the course. So they have the stats course first before they... We do not have a stats course. So this is the sort of the de facto data science? Yes, correct.
Other courses are actually reducing the number of classes to make room for this new course. Yeah.
Feng is a course head of another course, so he's getting his workload reduced.
Totally, yeah. So this is how ChatGPT is helping me, right? Reduce the workload. So the other courses are becoming less relevant, so we can teach less. Yeah. Okay. So thank you so much, Chiara.